Okay, so today we're going to be doing lesson 10-1, simplifying radicals. Okay, the first one, number 1, it says radical 50, or the square root of 50. And so I look here and I say, is there any perfect square within 50? And there is. I can get a perfect square of square root of 25 and the square root of 2. Because 2 times 25 is 50. They're both square roots, or both radicals, so I could multiply these together to get the square root of 50, but I broke it down. So now I have, what's the square root of 25? Is 5. What's the square root of 2? Without a calculator, I don't know. So that's my answer, 5 square root of 2. Okay, so we're going to continue, and we're going to look at square root of 18, or radical 18. There's no, what I'm calling a perfect square, I'm not sure if I'm saying that correctly, but a perfect square root. Okay, there is a 9 in here, because 3 times 3 is 9, times 2, that's 18, but then I need to put square roots around them, because 9 times 2 is 18, and they're both square roots, so it's the square root of 18, or radical 18. What's the square root of 9? 3 radical 2. And that's my answer. Okay, the next one, we have a negative 5 on the outside. I'm going to keep that negative 5. I'm going to break down my radical, or square root of 300, find a perfect square root, which is 100, because 10 times 10 is 100, radical 3. I keep my negative 5. The square root of 100 is 10, and so this is a multiplication problem. It's 10 radical 3. And then I'm going to take negative 5 times 3 is, or negative 5 times 10 is negative 50 square root of 3. So I multiplied the numbers, multiply with numbers. Radicals can multiply with radicals. So negative 5 times 10 is negative 50, and I keep the radical 3. Because I can't simplify it, I don't have a calculator, so I'm going to leave it just like that. Okay, now I got 45 and the square root of a to the 5th. So square root of 45, not a perfect square, so I'm going to break it down, and I've got square root of 9 square root of 5. Because when I multiply these together, I get the square root of 45. Okay, with letters, what you can do with letters is we can take the 5 and we can divide it by 2. So 2 will go into 5 2 times, and there's 1 left over. Okay, so if I do this, I can take, I get x to the second, because that's the whole number that's here. So that's where that 2 goes. But then there was 1 left over, so it's going to be square root of x. Square root of 9 is 3, and then this radical 5 will go inside the square root there. So my answer is 3 x squared radical 5x, because anything that's left over that's in the square root is going to go together. The numbers will be on the outside, and the letters without the square root will be on the inside. Okay, so let's do another one of those. That's a little bit confusing. Okay, so now we're going to take, and we're going to keep our negative, because it's on the outside of our square root. Okay, I'm going to take x squared, and I'm going to divide the 2 by 2. So we're going to take this exponent and divide it by 2. 2 over 2, or 2 will go into 2 once, so that becomes just the x. I take the y to the 5th power. I'm going to divide it by 2. 2 will go into 5 2 times. Okay, because 2 times 2 is 4. So I have y to the 2nd. That goes in the outside. But what's left over from this y? There was 1 left over. So I'm going to put that leftover 1 in a square root. So there's my answer. I keep my negative, because that was on the outside of the square root symbol. I take this exponent and I divide it by 2. 2 will go into 2 once, so that's on the outside of the house, or the square root symbol. I take the 5 and I divide it by 2. 2 will go into 5 2 times. I put the 2 exponent with the y outside of the square root symbol, and what's left over I put inside of the radical. So there was my answer. Okay, next part of this, move up. Alright, so now I look at this, and there's a couple ways you can approach these problems. I'm going to show you one way by looking at them separately. So the 8, can I break it down and find a couple perfect squares in here? Square root of 4 times square root of 2, which gives us the square root of 8. So I have 2 square root of 2. Then I can go over here and find a perfect square within here. I got square root of 4, the square root of 3, which gives me 2 square root of 3. Okay, remember these are multiplication problems. So I'm going to multiply. The numbers can multiply with numbers. So 2 times 2 is 4. Radicals can multiply with radicals. Radical 2 times radical 3 is radical 6. That is one way to do this type of problem. The other way to do this is to take 12 times 8. 12 times 8 is 96, and keep it under the square root symbol. And then we can break this 96 down into square root of 16 and the square root of 6, because 16 times 6 is 96. And then I have the square root of 4, square root of 6. So both these answers are exactly the same. We just did it in a different procedure, and both of them work. Alright, number 7. We're going to keep the 5. Okay, I look, there's no perfect square within here. There's no perfect square within here, so I'm going to multiply these two radical symbols together. So I get 6 times 3 is 18. Then x times x is x squared. So then I'm going to go from here, and now I'm going to look to see, can I take a perfect square out of here? And I've got radical 9, radical 2, and then I have the square root of x squared. I still have the 5. Now I'm going to simplify that. Okay, so now I'm going here. I keep the 5. Square root of 9 is 3. This is multiplication. The square root of x squared is just x. So all these are outside of the square root symbol, but we have a radical 2 left. Okay, now the next part of this, you're going to go multiply numbers, go with numbers. So 5 times 3 is 15. X radical 2. And that's your answer. So let me write it up here so you can see it a little bit better. So we have 15x radical 2. And that's my answer. Alright, next part, number 8. Now we have a fraction within a radical symbol. The best way to approach these is to break it down. If you can simplify or divide inside the radical symbol, do that first. But we can't. We have 11 and a 49. So now I'm going to say this is radical 11. And then at the bottom I have radical, or square root of 49. Is there any perfect square within radical 11? There's not. It's just radical 11, or square root of 11. Square root of 49 is 7. And so I broke that down. That's the simplest form. And I'm finished for number 8. Okay, number 9. Okay, now I look and I say, okay, could I simplify this? I could, but I think if I broke it down into 2 separate radicals, I can do it almost in my head. So square root of 144 is 12. Square root of 9 is 3. I'm almost there. Can I simplify? How many times will 3 go into 12? 4 times. So that's your answer. We simplified it all the way down. Okay, number 10. Alright, we've got two fractions here. I look at the top, square root of 88, not a perfect square. Square root of 11, not a perfect square. So why don't I try, can 11 go into 88? And it can, and this is going to make it smaller so I can have something smaller to work with. It's 8, because 11 will go into 88 8 times. Now, from here, do I have a perfect square within 8? I have a 4, square root of 4, and a square root of 2. What's the square root of 4? Is 2, square root of 2. And that's my answer right here. Okay? Next part. Number 12. Okay, so now, can I simplify what's inside of here? Because I don't see a perfect square there nor there. Let's go ahead and simplify 12 and 27. Can I divide each of these by a 3? Can I take a 3 out of the 12 and make it 4? Can I take a 3 out of the 27 and make it a 9? Can I also make the top by subtracting and make this an a squared? Okay, because 3 times 4 is 12, 3 times 9 is 27, and then I subtract the exponent here and got a squared. So now I can take square root of 4, square root of a squared, and the square root of 9. So I have a 2 at the top, I have an a at the top, and I have a 3 at the bottom. So that is my answer. I have a 2a over 3. Okay, this next one. Do I have a perfect square at the top? No. Do I have a perfect square at the bottom? No. Can I now simplify? Will 5 go into 9? We have 1 time, and there's 4 left over, right? Will 5 go into 40? And that's 8 times. So now I have the square root of 18. Do you see that there's a perfect square within 18? Hopefully you're kind of seeing what we're doing now. Square root of 9, square root of 2. Simplify that as 3 square root of 2. And that is number 12. Okay, the bottom are numbers 13, 14, and 15. We are going to rationalize the denominator. And what that means is at the denominator of our fraction, so the bottom of our fraction, we cannot have a radical symbol. So in order to undo a radical at the bottom, you need to multiply to make a perfect square to get rid of the radicals. So if this is square root of 5, I could multiply the bottom with another square root of 5 to get square root of 25. But what do I do to the bottom? I have to also do to the top of my fraction. So I'm going to multiply the bottom by the square root of 5 to make radical 25 at the bottom, or square root of 25. And at the top I have 2 square root of 5. Okay, what's the square root of 25 is 5. Is square root of 25 a perfect, or square root of 5 a perfect square? And it's not, so I'm just going to go ahead and keep this. Could I cancel the numbers out? I can't. So there is my simplest form. Okay, the next one. Okay, I have 2 separate radicals here. I have a radical 7 at the top, and can I do anything with radical 7? And I can't simplify it. Then I have a radical 8 at the bottom, and I can't simplify that. So then I look and I say, okay, I need to rationalize the denominator. I need to get the denominator to be a perfect square. And I have an 8. Well, 8 times 2 is 16. Is 16 a perfect square? And it is. So I'm going to multiply this by square root of 2. And then I have an n, which is not a perfect square. But if I multiply it with another n, it'll create a perfect square. So what I do to the bottom, I have to do to the top. Okay, so at the bottom we have 8 times 2, and that's 16 square root, because we have a square root of 8 times the square root of 2. Then we have n times n is n squared. At the top, we have 7 times 2 is 14. So we have the square root of 14n. Okay, now at the bottom, square root of 16 is 4. The square root of n squared is just n. And at the top, I have square root of 14n. Okay, and then I look at 14 and I ask myself, can I take a perfect square out of 14? It's 1 and 14, 2 and 7, no, and there's no perfect square there. So therefore I've got my final answer. Radical 14n over 4n. So that's my answer there. We've got one final one. I'm going to scoot this over just a little bit. So I have a little bit more space over here. Okay, now I look at the 2. And I say 7m, is that a perfect square? No. Radical 10, is that a perfect square? No. So I'm going to go ahead and break it up with 2 radical symbols. Put that at the top and radical 10 at the bottom. Okay, I want to create a perfect square at the bottom, so I'm going to multiply both top and bottom by radical 10, because 10 times 10 is 100. So at the bottom I have radical 100. At the top I have 10 times 7 is 70m, and it's radical. Okay, then I look at the bottom. I've got the square root of 100, which is 10. And then I look at radical 70 and see if there can be a perfect square taken out of that. And there can't, so I'm just going to keep the square root of 70, and I keep the m. So right here is my simplified answer, where I rationalize the denominator of this one. There's no more radical symbol in the denominator. Same with number 14, there's no radical symbol in the denominator. And on 13, no radical symbol in the denominator. So therefore I rationalized, I'm going to go back to the directions on this. I rationalized the denominator. Oh, alrighty.